The ocean floor is a mostly untapped reserve of valuable mineral deposits. But how can deep-sea mining affect life in the ocean? To find out, we're joining a research cruise in the middle of the Atlantic. The mining industry is developing technologies to extract metals and minerals more than half a kilometre down on the seabed. The first commercial mining is expected in 2018, and it's raising a lot of concern amongst oceanographers and marine biologists.
Ian, when we talk about deep-sea mining, what exactly do we mean?
Well, there are a number of deposits that are on the seafloor that people think may be exploited for commercial purposes. They're principally metallic, but also phosphates and methane hydrates for energy. There's a lot of interest at the moment, and there's a lot of investment going on. There are a number of projects that are going to be coming to fruition fairly soon.
Scientists fear that mining will greatly damage such a fragile environment, although it's hard to be certain exactly how, since deep-sea ecosystems have been poorly studied. To learn more, marine biologists are researching how exactly corals react to damage associated with mining.
This group of corals was subjected to mechanical damage, which can be a significant risk for a colony. This other group has been subjected to copper pollution in a concentration that would be sufficient to affect their physiology.
The damaged corals, together with an undamaged control group, are moved onto the deck of the research vessel and carefully attached to special structures, which will then be lowered onto the ocean floor. According to the World Wildlife Fund, about a quarter of the world's coral reefs are already beyond repair.
This research is crucial, as corals are the basis of the deep-sea ecosystem. We need to understand how they will be affected, because the rest of the ecosystem depends on them.
For this experiment, the research vessel is stationed over an underwater mountain which lies in the mid-Atlantic range, situated near the Azores Islands. The coral samples are deposited more than 200 meters deep at several underwater locations. At such a depth and lying in cold water without sunlight, the coral grows very slowly. The whole process is visually controlled with a remotely operated underwater vehicle.
Within that experiment, we monitor the deployment of the corals, and then once they are landed vertically, we go along and cut the deployment ropes, make sure everything's clear, and just take a positional fix of the position of the landers on the seabed so they can find them when they want to recover them in months' time, years' time.
This experiment should reveal exactly how coral responds to both mechanical and chemical damage in its natural environment. Although coral only covers about 2% of the ocean's bottom, they harbour about a quarter of all ocean species. In fact, coral reefs are sometimes referred to as the rainforests of the sea, and any data that can be gathered about them will be vital.
Scientists would always like more data. This is why we're on this cruise here. What we really need to understand better are the processes and the interactions in the deep sea and how they would respond to the mining activities. We still need a lot more research on this, and without more research it's very difficult to predict accurately what the effects may or may not be.